Good morning, good afternoon, and good evening to you all. A very warm welcome to our webinar, The Unified Space. A namespace is powerful for Industry 4.0, but how does it work? Thank you for taking time and attending this webinar. Join me in welcoming two special presenters for today. Kevin Jones, who is the CEO and lead strategist at Ectobox, and David Schultz, who is the owner of G5 Consulting. We are super excited to have you both today and to learn about Unified Namespace. Joined by Kevin and David is Ian Skerrett, VP of Marketing at HiveMQ, who will be helping with Q&A. Before we kick off this session, I would like to share a couple of housekeeping pointers. We are recording this session and it will be shared in a follow-up email. All participants will be on mute. If you have any questions during the session, feel free to type them in the Q&A box in the control panel of the Zoom window. We will answer these questions during the Q&A session. And we will be running few polls during the session. I request you all to participate and cast your votes. Also, feel free to interact with everyone in the chat pod that's also available in the control panel. Now, without further ado, I will hand it over to Kevin. Over to you. I'll stop sharing my screen.
Thank you. Thank you very much. I appreciate everybody at HiveMQ making this opportunity available to talk. David and I have some really interesting topics around the idea of unified namespace that we'd like to share. So with that, we will start right into it. We'll go over the basic agenda and then we'll go from there. So we're going to start off by setting the context around the background for unified namespace, and I think it would be helpful to mention the fact that we are coming from the perspective of manufacturing. That's a lot of the use of unified namespace for us and a lot of the work that we get into. There are probably attendees here that are from all kinds of industries and all kinds of countries. And so with that, we're going to come at this topic from the manufacturing perspective, and you'll see some very specific manufacturing examples, but hopefully you'll be able to translate those ideas into other industries as well. We will then get into the big question of what is the unified namespace. We'll of course apply it to manufacturing, show any number of examples to hopefully get the idea to become much more concrete so that people can understand it. And then we're going to take a step back and review again, hey, why is this important? And get into a few details on how to execute, and then of course Q&A. Throughout this process, as Jayashree has mentioned, we'll do some polls. One should be coming up here pretty soon. These polls are going to be really helpful for us during the conversation. If we can see the results, then we can know where to guide the conversation. And feel free to throw out some Q&A questions during the process. Ian, on this conversation or in this webinar, he'll be able to hopefully interrupt us and let us know if there's an important question we should really address during the session. If not, they can be left to the Q&A time.
Hey, Kevin, I'm going to interrupt you right there because there was a question and I think it's a good idea. Could you go into presentation mode? You're kind of with your slides. I think it would be a better experience for the webinar participants.
Sure, sure, no problem. Okay. Let me switch this over. I apologize for the interruption. This is actually going to be, I typically present like this so that we can see the slides before and after.
Okay, then keep going. That's fine.
Okay, great. Prefer that. Sorry. Appreciate it. Thank you. Before we go any further, we'd like to do some basic introductions. Dave, who's with us, owner of G5 Consulting, is a widely known solutions architect around these kind of solutions. Dave, you want to say anything else about yourself?
No, as you mentioned, I'm the owner of G5 Consulting, solution architect. We work to help lead people through their digital transformation journeys and architect those solutions on where they start. So a lot of experience here. I've been in manufacturing, process control automation for 25 years now. So it's hard to believe it's been that long, but here it is. So thank you.
Yep. And myself, CEO, lead strategist at Ectobox. We're a Industry 4.0 systems integrator for manufacturing companies, and we have a very similar focus. We focus on helping manufacturers operate more efficiently and grow by implementing solutions like this. So with that said, let's set the context. Manufacturing, where you make things. There are a lot of challenges with manufacturers today. We're based in the US, but we also have a perspective on manufacturers in South America, Central America, Europe, Asia, all over the place. And there are a lot of challenges, more challenges today than there used to be. Those challenges are at the global level here, as well as at the level that every manufacturer has always been dealing with: machine downtime, production throughput, quality. All these kinds of challenges have always existed. But the question is, how are manufacturers going to solve all these kinds of challenges that they have in the plant? Well, the idea is that they should be using data. They should be driving for deeper visibility into the factory floor. But typically, a lot of companies have an ERP system at this level, enterprise resource planning system that does a lot of the strategic work and planning. And then they have the plant floor. But what's in between these two? Pieces of paper and spreadsheets very often. Some companies do have software and really nice networks of systems to integrate and connect together and share data, but not all the companies do. There's a big missing space here, and this is usually where we start our work, and this is where the unified namespace becomes really valuable very quickly. So when we're talking with companies, our hope and our expectation is to connect everything and everyone into the network. And then at that point, everybody at all layers of the organization understand and can operate based on that data from all the other layers in the organization. Stakeholders can have the current state, understanding of the current state and the future state of the business in real time. So they're going to be working on becoming a data-driven manufacturer. But how do they do this? They need to use data, and they need to have that data connected into a single system, into a single version of the truth. That is a key piece of success for companies and their digital transformations. But another picture of what the current state is in manufacturing, they very often rely a lot, almost wholly, on their ERP system, their enterprise resource planning system. And then they have other systems throughout their company that will do small silos of work or effort. And they'll try to become a data-driven company by integrating one system to another with discrete connections. But those discrete connections can be very difficult to maintain, and it's difficult to remove and install a new software application for that particular need, because then you have to reestablish all of those discrete connections. Wouldn't it be nice to have one place to go for your data, to have this single version of the truth? We like to put architectures in place like this that use a unified namespace, where you publish data into this unified namespace and can subscribe to that data from any other system, so that each system, including the ERP, becomes a node in this ecosystem. The ERP is not the center of the universe. Now this central system, the unified namespace, is a part of this. And a lot of the ways that we communicate technology-wise is using technologies like MQTT, SparkBugB, especially for the machines. And we use other technologies to communicate with other systems in this whole unified namespace. We're not going to get too much into the integrations of the applications and how all that works. HiveMQ and their group have spent a lot of effort to put out a lot of good information on their in their webinars and YouTube channels and all that about the connectivity piece. We could get into that, but we're going to focus on the unified namespace. What's at the core of all of this? So what is the unified namespace? I'll go through a little bit of this and then throw it over to Dave to get some additional comments. What I'd like to do when defining things is to start at the core. What is a namespace? Forget temporarily the idea of a unified namespace, a UNS. What is a namespace? Well, to me, it's a system to identify and uniquely refer to related concepts or objects. And they do need to have those unique references. And so we are essentially looking at, here's an idea, and here are additional objects or concepts that are related to that idea. We'll refer to that as a namespace. We're going to give it a name, and then what we do in this whole unified namespace concept is then include that namespace with a whole bunch of other namespaces to organize a lot of information regarding a manufacturing plant. So what we are actually doing with this unified namespace, or each of those namespaces, is to define the structure of the business. And then we are making this unified namespace the hub of communication of all of the smart devices that will communicate over MQTT, Sparkplug-B, and other technologies. With that, because we have the structure of the business and we are creating a hub of communication of all the smart devices, we are then getting the current state of the business in real time in that unified namespace using products like HiveMQ and others. That then gives us that single version of the truth. Because it's a hub, its current state, it gives us that single version of the truth. And then because it also illustrates the structure of the business, it then becomes the foundation of a digital transformation initiative. Companies are in this place where they have an ERP system and a bunch of other discrete connections and pieces of paper and spreadsheets. They want to move to a fully connected system, Industry 4.0, smart manufacturing, digital factory. How are they going to get there? They're going to need that single version of the truth. And so that then becomes the foundation of those kinds of initiatives. Dave, is there anything else you think would be helpful to add to this conversation?
Yeah, I'm going to abstract it up just a little bit more. So, we get asked a lot, well, is a unified namespace, is it a piece of technology? And well, sort of. There's parts of technology that make it up. But from my standpoint, it's more of an architectural consideration, design consideration. It's a strategy of how are we going to bring all of these systems together to communicate with one another, whether it's using like an MQTT broker or some other technology to ensure we're passing data from one system to another, but it's going to be done in a way that we all agree on that data structure. This is where I get into these semantic data models, to use a term I use a lot. And that's really that design consideration. So, then once you start applying that strategy, that design approach, that architecture, that's where you start filling in the holes with things like HiveMQ to work with your what I call SCADA data, sometimes called as telemetry data. That's a very good technology for passing a lot of that real-time information back and forth.
Yeah, that makes sense.
There's a question that came in that I thought might be a good time to come in with. Is there an application or use case of UNS already for during the engineering phase? So kind of the engineering phase of, I guess, kind of engineering of the product kind of that's being manufactured. Can either of you respond to that?
I'm sorry, could you repeat the question? Is there an example that's
is there an application or use case for the UNS during the engineering phase?
So just for the engineering design piece, for the technologies that are there, or it's, I guess, where I'm a little not understanding the question.
Okay, so let's keep on going. And
okay, apologies.
Yeah, okay.
Yeah. Well, I mean, from my standpoint, yes, if you're in the engineering phase, you should be applying the strategy for it. But in terms of, like, if you're using engineering technology, like say you're doing PLC design review, yeah, absolutely there is. But this webinar is really more focused on the manufacturing components themselves.
I think there are probably ways that we could weave that, and I'll keep that in mind as we go through the conversation, because there are a few different ways that engineering reference could be used. With that in mind, I just want to pause real quick. Jayashree, would you mind, if you haven't already, throw up that first poll about the experience around unified namespace? That'd be interesting to see those results.
Sure.
Thank you.
I will launch the poll now, and let's give it about 30 seconds for the attendees to cast their votes.
And while they're doing that, I'll just continue with the conversation here to keep things moving along. So let's keep going on about what this unified namespace is. So keep in mind, we're talking about, in the previous slide that you can kind of see here on the side, structure of the business, hub of communication. We get the current state of the business, or of all the data. It becomes the single source of truth. With that in mind, and then the question is, well, if we're using namespaces, this concept of uniquely identifying objects that are related to one another, how are we organizing them? What we're doing is we're using a concept from the ISA 95 standard, part 2, enterprise site area line cell, as a way to look at how a manufacturing plant is organized, and then organizing the various parts of that plant into these slots, if you will. Oh, good results. Starting to learn about UNS, beginning. Great. That's fantastic. So some of you have done it. That's really awesome. Appreciate you guys being here. And if you guys want to participate in the conversation in the chat tool with everybody else to lend some experience, some wise words, please do. Beyond that, I think we'll then really make sure that we focus on the basics so that everybody can come up to speed about what the UNS is. Really appreciate you responding to that poll. That's really helpful. So with the unified namespace, we are organizing the data at the enterprise level, and then within the enterprise, what site or sites you have, locations, and then within that site or location, what areas you have, what manufacturing lines are in that area, and then what cells are within that line. Cells, typically PLCs, machines, etc. So I created a very basic example. Let's pretend that Coca-Cola Coca-Cola is a company. Let's pretend that they have a manufacturing plant in Pittsburgh, Pennsylvania, in the US, where I'm based. And under that site, then we have areas like a bottling line. And within that bottling line, we might have line 1 and line 2. And then within line 1, we have a PLC and the PLC's tags. And you would see listed under there all of the tags. We also include in this whole unified namespace other namespaces like functional areas, the ERP system, and some data that we'll get from that ERP system as we integrate things from various parts of the company, like what the work order is, what the routing is, what the schedule is. Then with this whole namespace, we can use this structure across the whole organization to be able to know where the data is, to get that real-time visibility into the current state. And we're going to see that data. This is the structure of the business. This is how we order the structure of the business. We're going to start to get into some really good examples, and Dave's going to start to lead some of that discussion. Let's stop for a second and use this slide as a picture to set some more context. This is a slide similar to an architecture that we have been discussing with a particular manufacturer with certain information abstracted and pulled away from the illustration. But this illustrates the idea that there's an ERP system here, happens to be SAP. That ERP system is providing data into this UNS, this unified namespace, and then provides data to a scheduling system. That scheduling system is used by a production scheduler. They push data back into the unified namespace. Then that information is shared and pulled by an operator to know what products to work on. It's pulled by the MES, the manufacturing execution system, to be able to run the plant. Data is shared from the machines, here up through a few levels, through an edge gateway, into the unified namespace, and then the historian, a time series database, consumes that data and then processes that data so an engineer can solve some problems in the plant. All kinds of situations you can see displayed here. So this is the context that we're working within with a unified namespace. And the examples that David's going to get into will illustrate some of these ideas. Ian?
Yeah, so a couple of questions. Does the UNS store the data or simply forward it to subscribers? Is the UNS a database, a historian, et cetera? I think, and there's another kind of question, what type of database do you use? So I think there's a general question about kind of the persistence of the information.
Great questions. Great questions that we get a lot. David?
So the UNS is not a database. It is merely a method of exchanging information, whether that's an MQTT broker with Sparkplug B payloads, or it's some kind of messaging queue. It can also be an endpoint for querying, but all it fundamentally is that it's a single endpoint for doing a lot, or for getting all of your data combined. All the underlying systems that connect in with it, that you'll notice here on this diagram that there are, your ERP, your CMMS, your MES systems, those will all have a database for all of that data storage. So the only type of persistence you get, you say specific to an MQTT protocol, is if there is a retain flag that is set, so that any new node that connects in can at least get a payload of what the current values are, and and that's the really only kind of storage, if you will, that sits there. But fundamentally, this is to give you a snapshot of your business in real time, that if you wanted to know certain things like what's operating on line 1 in plant A, you'll be able to determine that right away. And then if there's an issue, that's when you'll go into the relevant subsystems, start taking a look. Like Kevin mentioned, the historian earlier. Historian's going to be capturing the information that's exchanged through the UNS. You're going to historize that information, namely tag values. And now you can go back in the trending tool and take a look at what that looks like. Does that make sense?
Yeah, there's a follow-on question that's probably relevant to Ken. Is this where HiByte comes into play?
Yeah, so what HiByte is used is to actually provide some of that structure. So HiByte's a tool, they'll refer to it as data ops. And what the data ops is doing is it's connecting to SQL, it's connecting to API, it's connecting to cloud infrastructure, it's making a lot of different connections. And then based on what the underlying data set is, we'll actually use that with HiveMQ for that an MQTT payload if we need to say get ERP data into the line so we know what's being done. So that's the role of HiByte here. And as I mentioned earlier, there's other technology that fits into building this, but a UNS is not so much of a thing. It's when people ask where does it exist, well, it's everywhere. It's a strategy, it's a design methodology, but it's a way to organize all of your plant information, all of your asset information, and exchange things around through a common ecosystem.
Yeah, I'll revisit this slide too to kind of lend the idea that it's an idea, it's a concept, it's an architecture, it's an approach. Mm-hmm. And that approach provides you with the structure of the business. This idea, this architecture becomes the hub of communication, and it provides, here's the answer to the database question, gives you current state. So systems are constantly updating data into the system. So these machines are producing data. They are then publishing data, MQTT Sparkplug-B data. This edge gateway will publish MQTT data into the unified namespace, and then the historian will subscribe to it. But to be clear, if we're talking about publish and subscribe and MQTT and Sparkplug-B, clearly there has to be a technology in there somewhere. So we're taking this approach, this unified namespace approach, and then layering under it certain technologies to execute this idea, this architecture, this concept. And it's those technologies that enable us to do the things like have a historian subscribe to the MQTT Sparkplug-B data and then pull it down and store it. So again, this is providing current data, and then any system that wants to have that data, they can have it, and they can have any and all of it, and they can provide all of the data throughout this whole structure if you want. The real power, one of the big things that I really like about it is that it provides you context. Data from a machine alone is meh. It's useful, it's nice to have, but once you combine data from that machine with the work order you're working on, the product, the materials you're using in that product, the operator and how good they are, maintenance and a whole bunch of other things, then at that point, once that context is created around that machine data, the value you can derive from all of this data together is enormous. And that's where the power of the unified namespace really comes into play, providing that connectivity to all of the organization across the telemetric data, the machines, as well as the transactional systems, combining that into one place and then allowing you to pull that data and work with it.
Okay, I'll let you get back to it.
Thank you. All right, Dave, let's get into some examples. Now that we've provided this context here, let me open up the first diagram. And as we're doing this, Jayashree, could you please also run the next poll around is this powerful?
Sure. I guess some of you are not able to use the chat option. We are trying to fix that. You can add in your comments in the Q&A section until we fix it. And now let me launch the second poll. I'll give it about 30 seconds to 1 minute.
Okay.
It's up now. I request you all to participate.
Dave, we'll just hold on for a couple seconds here.
Sure.
Because you're about to dig into some deep stuff. I don't want anyone to miss it.
Absolutely.
good time for a coffee break.
Yeah, right.
Okay.
All right.
So, David, with all of that said, can you tell us a little bit more about the unified namespace with these diagrams?
Absolutely. So what we're looking at here is a unified namespace that has been built across a fictitious enterprise with some sites and some lines and various functionality that exists within their overall system. And I think where people are, where the challenge always is I don't get the UNS. What do you mean it's all of this information that is put together? And so what I'm trying to demonstrate here is it provides the context utilizing ISA 95 in terms of where does this function or where does this information exist within the relative position of the enterprise itself. So in this case, we're going to look at some functionality that exists within an enterprise, more of the transactional type system. So in this particular instance, because I'm building out a site, we're going to have perhaps somebody at that location. They have access to a CRM, that's your customer relationship manager, and they've recently just done a quote. So the most recent quote that was presented to a client, in this case, it's Hank Hill with Strickland Propane, big shout out to King of the Hill, and what it is that he's looking for. So it's some standard orange juice, the item, the number, amounts, and what that unit of measure is. So rather than having this sitting in some kind of SQL table, you can now in real time see what was the latest quote that was sent out from this particular site. Scrolling down to the ERP, you can now see we now have issued a purchase order because we need to manufacture some products. So I've issued a purchase order. In this case, it's going to go to Brian Adams over at Sentient Food Colors. And this is what it is we're going to get. We need some juice color in order to make something. And there's our purchase order, a quantity, unit of measure. So similarly, instead of having and typically these will be made up with a lot of joins within a SQL database, but we're now presenting the relevant information in a way that makes sense. Or we've now received a purchase order from one of our clients. So maybe Hank Hill liked what it is we're going to do, and he's now issued a purchase order for 4,800 cases of our standard blue juice. So this is now the work order. But what you're looking at here is the most current work order, purchase order quote that we have done for this particular site. And so this is now going to get moved through that enterprise. The purchase order is now going to trigger an event that, okay, we have a production order. We now need to move that to scheduling. But all this is made in real time, so I can very easily see what the enterprise is doing or what that current site is doing in terms of some of my business functionality. So if you want to move on to the line. So on the line overview, this is now going to get down into the actual piece of equipment itself. And one of the powerful pieces of utilizing a unified namespace is that you can both have tag data. So remember, this is in manufacturing. We're going to be talking to tags that exist within a PLC that are used to control and operate the line, is that we're going to utilize the concept of some parameters. And so when I'm designing these types of data models, what I use parameters for is that static data. So I can assign with it what my area is. If I have, and this comes from my CMMS, this is my asset ID. So I can start tying those systems together. I know what the particular line number is, and I know the site. So as I'm looking at this data payload anywhere in my organization, I have some metadata, some information about the information that's coming from, what exactly am I looking at? And now I'm going to see all of these root folders that sit there that either refer to a lower level in the manufacturing hierarchy of the ISA 95 Part 2, and you'll see that in green with the cell 1, 2, and 3. I also bring in the concepts of some level 3 information. I have some MES information. I have some OEE information, and all that information is now presented as a unified structure of information, manufacturing information that's coming from that particular enterprise. So again, in real time, I can see what are my counts, what's my current run OEE, those types of things. But this is what that line overview looks like. You want to go over to the cell. That should be a cell overview. So now getting all the way, pushing all the way down to the very bottom, very similarly, I can have the cell parameters. You can see the information that exists within a particular cell. So I'm going to get my actual in-feed, out-feed states of that particular cell. I'm also going to know, you'll notice there's a CMMS piece there. So that's another MES function that I've associated with that particular cell. So as I mentioned earlier, it's that data is structured in a way that is unified throughout your organization, and it's presented in a way that makes sense in order where it is. Enterprise information, probably more CRM purchase order, work order, where within an actual cell or an asset or a piece of equipment, I'm probably going to have a work order that's associated with that, a maintenance work order that's coming from the CMMS. So going to stop real fast. This is going to be the overview of what that equipment structure looks like. I'm curious if there's any questions or comments that people had on that. And if not, then we'll keep moving into some of the more functional pieces.
While Ian's looking at some of the comments, we got an overwhelming response from the poll that it sounds like people believe this is interested or this is powerful and useful, and that or that they definitely know that this is powerful and useful. So overwhelming majority think this is good stuff. So yeah, let's keep plowing. Ian, what do you have?
So I think that there's one question. We're getting tons of questions, or I'm kind of we probably won't be able to get to them all. But I think there's one question I think kind of could be kind of interesting just from the example is kind of how do you align time across the namespace and where events happen at different times? And I think there's another question about context. Like, so where does the context come?
Yeah, it's a great question. And the concept of time is you're looking at everything in real time. So whatever the latest count is, whatever the latest manufacturing work order is, whatever the most recent piece of data that has published through this unified namespace is what's going to be presented. So regardless of when this event occurred, whenever, whether it's that telemetry or SCADA data, whether it's more the transactional data of a work order, a maintenance work order, or an OEE that only updates every 60 seconds, you're going to have the most current data and information available to you through this unified namespace. So it's taking unlike data, making it like data, and it's presented in context, all at the exact same snapshot picture in time.
Okay, and just to follow up and kind of if you have to historize kind of high speed values, right? How do you deal with, how does the UNIS kind of handle latency?
Yeah, and so from this particular technology, you might not want to use, say, an MQTT broker for that if you have high-speed historization going on. So you'll utilize some other piece of technology to do that. The fundamental, the understanding of that is as you are historizing that high-speed data, utilizing whatever the underlying technology is, that information is also going to be captured and stored in context to some of the other information as well. And then it's going to get historized in, say, a process historian or, generically a time series database.
So David, then you're saying that maybe, let's say the historian might be connected over here directly to some machines for the high-speed data, but then the data is going to be aggregated, historized, and will go through the UNS at some point as well, still.
There's just a different technology bus. So I don't want to get confused on, oh, it's just a broker or it's just this thing. There's going to be other technology that's used to do that. The point is that it's going to be able to publish and consume in a contextual data model. It's the semantic data model that's critical to that. So that high-speed data that's coming in, remember we utilize an idea of it's this report by exception type of thing. That'll be our minimum technical. So if there's static data, that's what we exist in the metadata or the parameters in this particular case, that information is not going to change. We're only going to get the new values. So you're only having to transact that underlying data set that's changing.
I think it might be worth mentioning and talking a little bit about the minimum technical requirements that we typically use as well, which helps us land on this idea of the unified namespace being viable and products like HiveMQ and others being viable. The minimum technical requirements being lightweight, report by exception, edge-driven, and open technology. Dave, do you want to go through what those mean real quick?
So I'm going to start with the open. So, we talk a lot about not building a solution stack or building it in a common or a platform, if you will. It's more utilizing a technology approach that I can now utilize different technology to connect this. So it could be MQTT, it could be OPC, it could be anything as long as it supports this minimum technical requirement. We're going to get things connected together through an open architecture, an open ecosystem. The second one is lightweight. So remember, we're now going to start connecting a whole lot of intelligence across our enterprise, whether you're in manufacturing or not. And that information, that data, because there's so much, you cannot utilize some kind of a pull response type of approach, because you might be asking a question to something, there's no new information, and yet you're continually asking it every second through a pull response. So that's where we get into that that report by exception, or excuse me, on the lightweight piece. You want to make sure that you're not taxing a lot of your resources, your network resources. Then following on to that is the report by exception. So rather than a pull response, I am just going to publish. I am the client. I know when I have new intelligence. I know what my information looks like. I'm going to publish that at a time that makes sense because there's something new here. Now I'm going to tell you that. And then finally, edge driven. Again, all these devices, when I say edge, I mean, where is this intelligence produced? So you want to have that sitting, or you want that payload, you want to try to model this information as close to the source of that information as possible and get it into UNS in the shortest path you can. So there's not a lot of other information that has to come through.
Yeah, good. Thank you.
Mm-hmm.
So let's keep going here, keeping going on. What I'd like to do is actually take a quick pause. Let's think about what we've been really talking about here. We're talking about a concept, a system, an architecture that then has layers under it. In this concept, this unified namespace with the layers of technologies under it, is the model of the business of the plant, how it works, and it provides you the data in real time for what's going on by becoming a hub of all the smart devices within that system. And then gives you the access to the data in real time of everything that's going on, becomes that single version of the truth. And it seems as everybody agrees here so far, this is really viable. But let's think about why it's really viable. I typically look at this kind of question in three ways. There's short-term, medium-term, and long-term. A lot of companies want to put this kind of stuff in place so that we can get visibility into our current downtime of our machines. How much are our machines down right now? I can see, I had a call this morning with a company and it said, our operators are logging 8 hours on this machine. But that doesn't mean the machine is up and running that full 8 hours. It could be down half that time for maintenance and who knows what other kinds of challenges. So let's get that real-time visibility into the downtime, production, quality, on-time scheduling, et cetera. All those challenges that I said are in the plant up above. But to me, that's short-term. Those challenges will always exist, and if we have the right systems, we'll continue to drive those challenges down and drive down the cost and effect of those systems. But we also want to start to think medium-term and long-term as well. As a company, the more we can do with what we have these days, the better off we'll be. We can't always go out and buy a new machine because the money might not be available. It's very hard to hire people right now and keep them in the door. And so let's do more with what we have. Let's enable that company to survive and thrive in the medium term. Let's also build systems that the employee of the future, the young people coming into the workforce these days, want to work with. My 9.5-year-old son was almost born with a device, a digital device in his hand. He is going to want to have an effect on a company when he gets a job eventually, maybe next year, but we'll see. He's going to want to be able to see what's going on in real time. He's going to want to innovate. And people these days with systems that exist aren't able to do that because they don't have access to the information. So we want to give data to these people so you can drive the employee of the future, become a more attractive employer, and really innovate in the company. And then there's the long-term stuff. Once you start to connect your plant, and then you connect other plants, and you connect the other plants to the enterprise, which you can do with these kinds of tools, HiveMQ, MQTT, SparkPlug-B, the unified namespace, et cetera. It scales all the way up to the enterprise. Why not then look outside of the enterprise and look across your supply chain to your customers and to your vendors, your suppliers, and other partners that you work with, and share data with them in a secure manner. Get data with your supply chain, enable your products to become smarter, just like the Tesla cars do. Every night they get smarter, they get updates every night. Create a solid future for your company. Drive the company valuation. Depending on what role you're in, you're going to be thinking about different things. People in the C-suite will think about company valuations and driving the future of the company. People in product development and engineers will think about making the product smarter. People in supply chain areas want to share that data with customers and vendors. Essentially, you want to become truly a data company. Facebook, Uber, a whole bunch of other companies, they don't have assets, they have data, and data is that gold that they mine to drive the value of the company. The same with Tesla. Rolls-Royce does this with their jet engines, etc. You want to become a data company eventually. And that's where the unified namespace can take you. And so that's why it becomes really, really valuable. So we think of it in short term, but at the same time we're thinking short term. It's sort of like that phrase for pilots: think big, start small. You will eventually then scale to the other stuff once you get that architecture in place. Dave, any additional thoughts on this?
Yeah, no, and this is why the UNS is such an important approach to, a methodology and a strategy, is that we're not just thinking, how do I get my manufacturing data in a way that I can utilize it? It's how do I start exchanging this information across my entire supply chain, my entire value chain, so I can even not only connect my plants together, I can connect my business with another business. So when you look at that supply chain flow, and that's fundamentally where we're trying to go, that, in real time, where you're going to know exactly where all aspects of that value chain is and be able to connect your suppliers to your clients all the way through.
Yep. Yeah, exactly. Well said. Well said. Let's talk a little bit, for the time we have remaining, about how to execute. Then we'll move over to Q&A. So I'll take a little bit of this, Dave, and then you can continue the conversation. Anytime we're looking at any situation with any customer, one of the first things we need to do is effectively a gap analysis. Where are you at now and where do you want to go? All right, now let's create that roadmap, whether it's for one project, a pilot project, or anything beyond that. And then the next step, there's gap analysis, and the next step is to implement this kind of architecture. In this diagram, I'll break it down a little bit more. We want to start by taking an inventory of the business. As Walker Reynolds at 4.0 Solutions often says, 4.0 Solutions often says, take an inventory of the business. How does the business operate? How does the plant operate? How do each of the departments operate? And then take an inventory of the intelligence. What is the data that the company uses and consumes now? Where do they get it? And what data do they have that they don't use? And typically that's in the PLCs and all the other smart devices throughout their organizations. And also it's in those other siloed systems that are not connected. At that point, relative to what Walker Reynolds often talks about, I've inserted an additional step here: identify or ID a valuable use case to start. What is low complex, low cost kind of use case to solve and has very high value? Maybe you do a basic evaluation on a quadrant with those two axes applied, and you look at all of the projects you have available and areas you think you should focus, and then you figure out which ones have the lowest complexity and cost and the highest value, and you start there first. And then you connect it all and integrate it with the UNS. That's where you start to put in this whole architecture, this unified namespace. At that point, then you move on to presenting, learning from the information, and iterating in a cyclical process. That's how you can actually move from where you're at to where you need to go with that roadmap that you've identified in that whole gap analysis kind of process. Dave, what are some other ideas for how to execute these kinds of projects?
Yeah, so I'm going to go back to that IT, the valuable use case. And this is where sometimes people, we talk about a proof of concept, or we get into the pilot. And I almost hate to say those words, because usually pilot means, yeah, we tried that and it didn't work type of thing. It's that pilot purgatory. So when you start to identify what some of these use cases are, you mentioned earlier, think big, but start small. What you want to do is look at some gaps that are in your manufacturing process. One of the things that I look at is there a lot of paper that's going back and forth? How do you actually plan your execution? If your MES is an acronym for massive Excel spreadsheet, maybe that's an opportunity for you to start looking at how do we digitize more of this information. It's the traditional low-hanging fruit. The thing to keep in mind, and notice that iteration at the very end, is that you cannot approach each project as a one-off, or each of these effort. It's not a project, it's part of a strategy. Exactly. And you want to realize that whatever I do is going to build into that next thing. So, and this is where that UNS starts to become powerful, because if we're utilizing a data model with data governance, we're utilizing minimum technical requirements that we know all of our technology is going to connect and work well with another. It means as we produce this new information, it can be consumed across the enterprise. So everything builds upon itself. It's not a one-off, and you don't have to refactor and go back through and, oh, we built in technical debt, now we're going to have to rip all that out and start from scratch type of thing.
Yeah,
So
all good
and it's
points.
it's easy. It's simple, but it's not easy.
I like that. That's good. There's a whole lot more that we could get into too about digital strategies and putting all of this within the context of a digital strategy. But looking at the time, I think we really need to press forward given the number of questions that are there. So in a moment, Ian, I'll ask you to move over to some of the questions. But first, Jayashree, could you please put out the last poll question? What is your experience with MQTT? We're really interested to hear what your experience has been like. So we'll give a couple moments while Ian continues to review and summarize the questions.
Do I just start with the first question?
Maybe give a moment for the poll.
Okay.
I think.
Yeah. Okay.
Yeah, so I have launched the poll. I'll give it about 30 seconds to 1 minute.
Okay. This has been a great conversation, and I think this has gone very smoothly. We've provided a lot of good information here. So with that, let's start to go over to some more questions, and let's spend 15 minutes doing it, and then we'll wrap.
That's great. No, it's been fascinating. Lots of information, lots of questions. So
A lot of fun.
yeah, no, for sure. So I think the kind of one of the questions I'm really interested in too is how does the UNS differ from industry to industry? Do you see different patterns based on the different industry, or is it kind of generally the same approach, regardless of what industry you're in?
I would think the approach conceptually can be similar, but clearly the namespaces within this unified namespace are going to be different. For some company, many companies, you're not going to have a CM, I guess I'm looking at the wrong slide for that, for a CMMS, a maintenance system. You might not have work orders, but you might have something else within the organization. So it's up to the company to really define the structure of their UNS, and that's something that we often help companies with. But within manufacturing, this structure using ISA 95 is a structure that works really well. And we borrowed, the ISA is actually a manufacturing industry oriented organization. They're a standards organization called International Society for Automation. And the standard number 95, amongst other things, has defined this structure called enterprise site area line cell for how data and activities are organized within organization. But that's very manufacturing specific. Other organizations are going to use a different structure. So I think it even becomes a question at the beginning of what standard are you going to look at for how your organization is organized. Dave, is that fair? Do you have some other comments?
Yeah, I just say from an application or a practical standpoint, how does it look across different enterprises? For the most part, manufacturers do a lot of the same type of thing of, they quote things, they receive orders for things, they, manage orders or execute orders, they control the line, they control the process. They have raw material coming in, they have finished goods going out, and they bill and they ship and all those types of things. So from a high level view, as you mentioned earlier, yeah, a lot of this is pretty much the same. It's just the details are where you're going to see some variance, but across industry, the approach is generally going to be the same type of thing of we got smart stuff, let's get it connected in a way that it can start leveraging the intelligence that's produced by all the smart stuff.
Mm-hmm.
And I think just kind of, there's a couple of questions I'm going to hopefully try and generalize, but how do you get going? So kind of, as you guys know, kind of, there's no such thing as greenfield. These are all brownfields. And a lot of the technology out there isn't pub sub MQTT oriented, be it at the MES level, like kind of level 3 or down below. Kind of how do you kind of start to get going and look at how do you integrate all these things from a technology implementation perspective?
And that's a lot of what's going to come out of these early phases of inventorying the business. How do we actually take, a sales order and turn it into cash? What does that workflow look like from an, end-to-end type of situation? And then it's understanding what's intelligence there. And through those first two steps, you're going to identify what some of those gaps are. It could be, we have paper sales orders where we print out every morning. There's a big clipboard that has everything on, has all of our manufacturing work orders we're going to execute. That's all on paper. So, that might be that lower hanging fruit to go through, or it's the actual, I don't know how well my machine is running. So maybe I need to add in some NMES type thing. Or what I run into the most time is I have a lot of stranded information on assets that aren't connected. How do I get that information at least connected and presented to other parts of the business? And it could be something as simple as, gosh, can you at least connect our line to something where I can at least get some of that information off? And they're very simple use cases. They don't require a lot of investment. And through that, through the return that you get through that, or the value that is created in that process, that's where you can start then looking at, okay, what do we want to do next?
Within that question too, I'd say that there might be the question about, okay, let's say that my machine doesn't speak MQTT Sparkplug B as an example. How do we get that data in there? What we typically do then is to use tools like an edge gateway, whether it be a smart PLC like an Opto22 Groove Epic, or an industrial PC from Siemens or OnLogic or somebody else. Load up some software like the Ignition Edge software from inductive automation, and then do that conversion from that, whatever that protocol or technology is that machine typically communicates over, and get it into the protocols that we've established as a standard for our unified namespace, and then get it into products like HiveMQ, et cetera.
Okay. Moving on, so there's a question about kind of best practices and kind of, is there kind of reference documentation? How do people, I guess, kind of in general, how do people learn more about UNS and how to go about implementing it? And do you guys have any words of wisdom where to get more information?
Yeah, so the short answer is their documentation. So I am a member of ISA. Kevin mentioned this earlier. And one of the things we talk about is, boy, is there a standard for Industry 4.0 systems? You think about ISA 95, there's a mechanism and there's a method and there's an overall approach. Right now, we're still gelling around. It's just too new. We're too early in the process to come up with what some of those best practices and those types of things are. We're going to say, just because this is what we do regularly, is there are organizations like Ectobox, G5 that can help provide these types of things. I referenced earlier about helping lead companies and manufacturers through their digital transformation journey. There are a lot of different companies that can assist with that type of thing to provide that guidance. And that's really where it is. It's let's develop a plan and then start executing against it.
Yeah, and the reason that we're talking about there are companies like us that can do this is because this is not a big national or international standard out there. This is a new idea that has gained a lot of traction over the last few years. The acceleration of this idea of using a unified namespace and using open technologies, non-proprietary technologies, open communication between systems, and the other minimum technical requirements. All of these ideas are very new, and there haven't been any standards written for them. So this is why we're getting out here talking about these ideas, because people are finding that it's really viable and useful, and want to learn more. But the best place to go are, quite honestly, to us, our websites, or to other organizations that are providing this information, where we provide this information freely, because these are ideas that should be out there in the community.
Yeah, for sure. So what kind of security is always an issue? So can you talk about kind of security in UNS?
Dave?
Yeah, so from a technology standpoint specific to MQTT, this is one of the biggest changes that I think exist within these Industry 4.0 architectures, is that when you're connecting, I talked earlier about how the clients have the intelligence. We utilize client instantiated connectivity. So the way that you are on your laptop at home, your computer at home, and you connect into your banking system, you are a client that is instantiating that connection. It's done securely utilizing TLS, at your transport layer security. So the information that's flowing back and forth has been secured. Nobody can access it. And because it's a client driven or client instantiated, if there is an issue, I can always disconnect. I don't have to open any ports in order to make that connectivity. Now, yes, the broker does, but that sits in an area that, you know, commonly in a DMZ within a manufacturing enterprise, but I don't have to open up any ports to any of these systems. So client instantiation utilizing TLS becomes quite secure.
Okay.
What else do you have?
So I'm just kind of going through just quickly. You can mention the limitations of this architecture when you use an MQTT broker as a central broker. So, so I think you've been talking about a broker. Are there limitations that you can kind of talk about using that as a kind of as the center of the architecture of MQTT broker?
Yeah, technical limitations of a broker itself. I mean, if you're utilizing some load balancing and a clustered broker, you can connect thousands of devices into a broker. So from a technology standpoint, are there any limitations of how many devices or how much information you can support? No, not really. You can mitigate most of those, as I mentioned, load balancers, doing clustering, those types of things. From a functional standpoint, yeah, there are things that an MQTT broker is not designed to do. So I talked earlier about, say, being able to query information or storing some information type of thing. How, you know, that doesn't exist. But the MQTT technology wasn't meant to do that. That's where you start utilizing some other services that are going to consume this information that you've already presented in a way that's already in context, and it's aligned and it makes sense.
Okay. And kind of related, is MQTT reliable enough for business critical data transmission? Isn't best suited for telemetry data? What would be the options? Kafka, AMQP, others?
So the reason why we don't use AMQP as much is that it's more of a Microsoft proprietary type technology. And I know that that's going to, you know, create some the wringing of hands of people, but fundamentally there's not much many industrial devices that are there. So we utilize MQTT because it's a very lightweight protocol. It's fit, form, and function around SCADA. You know, can you use other systems with it? Yes, that's part of why, say, HiByte comes in, because you are going to need to support some other technologies, but it can all be presented through this MQTT/Sparkplug type payload. But if it's, you know, Sparkplug is really great for that SCADA, that telemetry data, but flat MQTT works so long as you have something that is managing and orchestrating all that transmission to assure, you know, it's more of a data governance type of approach.
Sure. And I'd just like to add to, for Kafka too, Kafka clients are very heavyweight. So to implement kind of an edge gateway with a Kafka client, you need to have a really big PLC to be able to operate as a Kafka client, right? And so typically what happens is for kind of, it's back to the lightweightness of kind of a UMS, right? You need to have kind of, the MQTT clients are very small in terms of their size, their complexity. It's very, very simple. And so that's typically, in our case, from HiveMQ's perspective, what our clients look at is just the simplicity of implementation too. Mm-hmm. So I think that the last question I'm going to kind of close with is kind of how do you convince your business stakeholders, right? Specifically, I think the question was the kind of the ERP has always been the single source of truth. Okay, so how do you convince the stakeholders to go about this change in approach?
I would take the Socratic approach, asking questions. So if you're talking with your leadership, so how much does the ERP system have access to within the whole organization, and be honest and truthful about it? The answer is probably likely not very much. And how well suited is that ERP system for dealing with machine data, with CMMS data, et cetera? A lot of ERP systems try to reach into that MES level to build some of that functionality, but how well does that functionality work within that ERP system? And with that conversation, then hopefully that might at least start to open up some eyes to realize, yeah, maybe the ERP system isn't everything we want it to be. There's a lot more value in the plant and what's going on. And maybe even illustrating this other diagram that I have here to say, okay, how real is this state? We have really valuable, really important people on the plant floor and very expensive machines on the plant floor and this ERP system. How many pieces of paper and Excel files do we have? How much real-time access do we have to that data? Ask these questions, the questions of which you already know the answers to. And then hopefully you can start to build up some momentum to say, hey, it makes sense to get that real-time visibility into the plant floor. And then to get that real-time visibility, you need an architecture, you need a strategy, everything else we've talked about. If that doesn't work, then the approach might be, well, then if I have enough power, capability, and maybe a small little budget, I'll do a small pilot project on my own to implement this and see if it works, see if it makes sense, see if it drives value, build up the political capital in the organization to say, look, hey, this works. We ought to be taking a look at this. With a maybe 15 seconds, Dave, any additional thoughts?